students. So today actually I will take a short class on vector. Why short class? Because this portion we will go slowly. So in a vector, today's class will be regarding your resolution of vector and superposition of vector. So resolution. What is resolution? I'm telling you first. You will see one thing that when you have a striker and you play carom, if your striker just strikes the coin in a side, you will see that the coins go in some another direction, but it doesn't some all the time it doesn't go in the same direction of the force applied by the striker, but it is going in some another direction. That means, do you think that if I apply with the striker 5 Newton force and it is going in some another direction, let's say with an angle theta with the line of force, then the force which is responsible for this coin to move in this direction is same as 5? Do you think? Now this is basically the topic today we are going to cover. So I am just trying to tell you the fact first. Fact is that whenever you have a force like this F, and then like say some coin is moving from this position to that position, so basically it is moving like this. So if you draw one axis here, a pair of axes, so this is my x and this is my y, let's say. So that means the coin is coming from the origin to this point P, let's say x comma y is the coordinate. That means what? It has gone a distance x towards this position till this much, and then it has covered a upside distance y, and then it has reached this point P. That means this force is the total force you have applied, but it is covering x horizontal shift and y vertical shift. That means some portion of this total force is working along x axis. So this is my imaginary force, okay, not imaginary, but I am just taking a portion for my simplifications, like for my the benefits, so that I can analyze the system very simply. So Fx is a force that is responsible for the x amount of shift in horizontal distance, and Fy is the force that is responsible to move the coin in vertical position. So that means this F is having two components, okay, so these are called components of force. Now one thing I want to tell you, that if you have a vector here, you can move this vector anywhere, but one thing has to be sure, that the direction and the magnitude of the vectors has to be same. So from here you can shift the vector here, or you can move the vector here. So if you move like this, your vector will not change, okay. So in this way we can shift the vertical component of force from this point to this point. So I can tell that this F force is having two components. One is your vertical one, Fy, one is your horizontal one, Fx, okay. in this scenario, how to calculate the component? So actually it was like this. I am again just drawing it nicely. So it was like this and like this, and my force was, let's say, this one. Okay, so it will have two component. One is this one, that is Fy, and one is Fx, this one. So if I take this triangle, okay, rectangle, and one thing I can do, this Fy I can write here, because I told you, if you keep the magnitude same and the direction same, you can move your vector anywhere, okay, for your calculation. So this was my Fx and this was my Fy. Now let me just remove this part. Okay, so now see one thing very clearly. If you consider this triangle, means this triangle, then if this is my theta, so I know that cos theta will be my base by hypotenuse. So my base is Fx, hypotenuse is F. So my F can be written as, like, Fx can be written as F cos theta. So my this component which is with theta is always will be my F cos theta. That means cos theta component. Okay, so that will be my always cos theta component. Now if I find out sin theta, so I can see that sin theta is perpendicular by hypotenuse. Now my perpendicular is Fy. Why? Because this is 90 degree, because it's a rectilinear coordinate system. So my this will be Fy by F. So from that I can easily write that Fy is my F sin theta, right? So I can always write that Fy component is my F sin theta. So whenever we will be having this thing like F resultant force, so we can split the force into two perpendicular components. This is very important thing, like for our mechanics. Okay, whenever we will be doing any math, we will be using this principle. So whenever we are having one force, we can split the force into two components. One will be your F sin theta, one will be your F cos theta. In the same matter for any vector, if your vector is say r, that is your displacement vector, you can represent this vector in a similar way as r sin theta component if this is theta, okay, then, and r cos theta component. So these r can be splitted into this and this. So instead of writing r, if I write these two component, then my calculation will be easier, okay, and we will see that later on. Okay, now this thing is called the resolutions of vector, and now it's time to see that how vectors superpose with each other. We know that vector, any a pair of vectors will not add in a very arithmetic way. So there are some procedures for that. So let's say I have a point here, and from that point I have two vectors working together. One vector is this one, A, and another vector is my this one, P. But see, in this case two vectors, like these two components of a single vector is perpendicular to each other, but in this case it's not perpendicular, right? So they have some angle, say alpha, between them. Okay, or theta between them. It's better to write theta, because alpha I will write again later on. So this vector and this vector, better we talk about force, because with force it is easier to understand. So if this is my F1 and if this is my F2, so they will create a what you say, resultant force. That means these two vector will add up and create a total force, right? Let's say I don't know the value and direction of the force, the resultant force, so I'm keeping it in like this, okay, somewhere in the middle. So I say, let's say the, like, instead of F2 I'm writing A and instead of F1 I'm writing B. Sorry. And this is my resultant R. So these all are vectors, so I must give vector sign. Now I told you already that I can shift my vectors for my calculation, keeping the magnitude and the direction same. So this B vector I am shifting from that corner to this corner, like this. So this is my B vector, right? Okay, I must write this B a little far, okay, or let me write here. Okay, so this is my B vector. What I will do right now, I have to find out the value of R. So we know that the R vector is mixture of B vector and A vector, but I cannot write value of R is equal to value of A plus value of B. This I cannot write. It can happen, but under some certain circumstances. Okay, so I will find today the value of R will be what. So to find that, we will extend our this A little bit and we will drop one perpendicular here. Okay, fine. Now see one thing. Let's say this angle is alpha. This angle is what? The angle with the resultant vector and our one of the vector, that is, let's say, A. Think about force. The vectors think about force. So A is a force. Okay. So if my this is okay. Now my total, this angle theta, this is theta. So this will also be theta, right? Because these are similar angles, right? Now if this is my B and this is theta, so from this small triangle, so I'm giving name A B C D, right? So my BD is what? Let's say I'm applying sine theta first. So sine theta is perpendicular by hypotenuse. So what is perpendicular here? BD. So BD by hypotenuse, that is my B vector, right? The value of B vector. I'm talking about value because already the direction is taken care by theta, right? So my BD I can write as B sine theta, right? So instead of this thing, I will write here my BD is B sine theta. So this is B sine theta. So only the value I am taking. Now what is the CD? Let's do with cos theta. So we know that cos theta is base by hypotenuse. So CD by hypotenuse, that is B. So I can easily write that my CD is B cos theta. Now we will use Pythagoras for finding the value of R. Okay, so if we use the value Pythagoras here, I can see that AB square is AD square plus BD square. So I will write here AB square is AD square plus BD square, right? Now AB square is my generally value of R. AD square is AC plus CD, right? So AC plus CD whole square, as AD is generally AC plus your CD. So these are, and BD is as usual. Okay, now I will split this thing. So I will see that AC square plus CD square plus BD square plus 2AC CD. Now BD square, that means B square sine square theta. So instead of, okay, first AC square. So AC square is A square. So A square. Then I have CD, that is my B cos theta. So B square, I am writing the values, cos square theta plus BD, that is my B square sine square theta. So this is my B square sine square theta plus 2AC and CD, that is 2 into AC, that is A, and CD, that is my B cos theta. So if I combine them, so I can get that R, value of R square is A square plus C. This cos square and sine square will become 1, because if I take B square common, so in bracket it will be, we will have cos square theta plus sine square theta, and that is 1. So I am writing directly here B square plus 2A B cos theta. So I am writing here again the thing what we have gotten, that is R square is my A square plus B square plus, so these are the vector sign, okay, plus 2 into A B cos theta. So what is cos theta? Cos theta is the angle between the vectors that we are like applying, okay. So we can find the value of R with this equation. Now you can see one thing, if my this theta angle is 90 degree, so cos 90 will be 0, so theta is 90 degree. In that case I will get R square is equal to A square plus B square, and that is 0, right? So this will happen in case my theta is 0, theta is 90 degree, okay. So that means this case. So in that case I can always write my value of total force is root over Fx square, value only, and Fy square, and the 2AB cos theta part will not be here because they are perpendicular. That means cos theta is 90 degree. If my theta is 0 degree, so that means cos 0 is 1, so I will be having this R is equal to A plus B, the value, only the value. That means we are applying the vectors in same direction. So that is matching our first what we have discussed. If my theta is 180 degree, so that means cos theta will be minus 1, so we will get R is equal to A minus B. That means my force or the vectors are acting in different direction, okay. So these are some special cases, okay, to understand how the vectors are being added with each other. Now what will be the value we have got already, we have gotten the value already, but how to measure the angle? So alpha is the angle, right? So for big triangle A, B and D, I can always write that my tan theta or tan alpha, because I'm taking the big one, tan alpha is, I know that tan alpha is basically my perpendicular by base. So perpendicular is BD and base is AD. So BD by AD. Now my BD is B sine theta. This theta is the angle between two vectors. This alpha is the angle between resultant vector and the base vector. Okay, that means the A. Okay, and and AD is AC plus CD. So AC plus CD. AC is my A and my CD is B cos theta, right? Because this was B cos theta. So also I have gotten the direction of my resultant vector. So now we can find easily that for like if I am giving you two vectors, okay, like this, I have given you two vectors, like one is this, another one is this, with an angle 60 degree with them. This is my 5 Newton and this is my 6 Newton. You should find what will be my value of resultant vector and the angle, like, or the direction of my resultant vector with 5. Okay, so obviously but resultant vector will be somewhere here, so you have to find out this angle and you find out the value of r. Okay, so try these things and we will do our further things after this. Okay, so practice once this thing, and this is very easy thing, I think. So fine, see you in my next one.